Good afternoon, all the participants and our resource person, Dr. Mala Kalra ma'am. Welcome, ma'am, to the session. Good morning, good afternoon, ma'am.
A very good afternoon, ma'am.
I'd like to first give a brief introduction of our resource person. Dr. Mala Kalra is working as a professor in Department of Computer Science and Engineering at National Institute of Technical Teachers Training and Research, Chandigarh, India. She received her BE degree in Computer Science and Engineering from MDU Rohtak, Haryana, and ME degree in CSC from PEC, Chandigarh. She obtained her PhD degree in CSC from Punjab University, Chandigarh. She has more than 16 years of teaching and research experience. Under her guidance, 35 students from have completed ME thesis and 2 PhD theses are in progress. She has over 50 research publications in reputed international journals and conferences. She is a reviewer of several journals of Elsewhere, IEEE, and Springer. She has got one patent published to her credit. Her research interests include cloud computing, Internet of Things, and information retrieval. She is having lifetime membership of Indian Society for Technical Education, Computer Society of India, and lifetime fellow membership of IETE. Welcome, ma'am. Welcome to the session of Data Sciences. The topic for the day is data exploration using NumPy and Pandas. Now, I hand over the session to you, ma'am.
So, very good afternoon to all. First of all, I would like to thank the coordinators for providing me an opportunity to deliver this session. I welcome all the participants in this session. So, first of all, let me share my screen. My screen is visible to all. Am I audible to all?
Yes, ma'am, everything is perfect.
Okay. So, thank you. In this session, I would be discussing data exploration using NumPy and Pandas, which are open source Python libraries. So, let us quickly review data science life cycle. The first phase is of data collection, where we fetch data from multiple sources. So, data can be fetched from different websites, or it can be obtained from various websites through web scraping. We can also collect data by retrieving data from various databases. So today I'll be demonstrating you how can we like explore the data which is collected in the form of CSV or JSON file from the websites. Next phase is of data wrangling or data cleaning. As you know, data is not in the proper form, so we need to convert it into a form so that we can apply data modeling over the data. Because let's say you have downloaded data from Twitter, so it will be having various hashtags, etc. So it need to be cleaned, like we need to remove the outliers, we have to uh, add the we have to take over the missing data, we have to handle the missing data, and we have to remove the noise, etc. So that comes under data wrangling. Then comes the EDA, exploratory data analysis. So after performing data wrangling, we perform EDA or exploratory data analysis. EDA is all about getting to know your data. This is done by getting basic description of your data. So this will further help you in selecting appropriate data modeling technique to apply on your data. So it includes getting descriptive stats of your data, extracting important variables. So basically, you are going to describe the basic features of your data and give short summaries about the data. Next comes the data modeling phase, where you train your data, where you test your data, and you can use this kind of data model for further predicting some kind of data or further classifying some data. And in later stages, you may be optimizing your data model. So in this session, I'll be focusing on EDA part. So I'll be discussing how can we explore data, or how can we get descriptive stats of the data using two Python libraries, that is NumPy and Pandas. So NumPy stands for numerical Python. It is a Python library which provides support for multi-dimensional arrays, and it also provides a collection of functions for processing those arrays. So the most important object in NumPy is ND array, which is uh, providing support for n-dimensional arrays. And this will be consisting of, ND arrays will be consisting of items of the same type, means it will be collecting values of homogeneous types. And like other programming languages, we can access the items using a zero based index. So you must have studied about lists in Python. And you may be thinking of that, when lists provide similar kind of functionality, why should we go for arrays offered by NumPy? Because NumPy arrays occupy less memory, provide high performance, and are convenient to use as compared to lists in Python. So that's why we should go for NumPy arrays if we are to perform some mathematical functions on multidimensional arrays. So this was just the basics of NumPy. Now we should move on to the practical demonstration of NumPy. So I'll be using Anaconda, basically Jupyter Notebook, for giving demonstration of NumPy and Pandas. So this is my Jupyter Notebook. So I'll be giving it name as NumPy Introduction. The very first thing is you need to import NumPy package, which can be done by writing import NumPy as, can give any name. So I'll be giving NP. So very first statement is import NumPy as NP. And for executing this statement, I'll press Shift Enter. So now NumPy package is included in my Python file. So how are we going to create ND arrays in NumPy? Let's see. So the function is np.array. So you should call this function np.array. NP is NumPy package. We are referring to NumPy package, and then we are referring to its function array for creating our array in this package. So first of all, I'll be creating n-dimensional arrays using lists. So the command is np.array, and I'll be passing list into this function as a parameter. So after executing, I'll be getting this as the ND array. Next is, as I have told you that NumPy arrays are of homogeneous data type. That means that the values present in the array will be of the same data type. So let's see what happens if I create a list of heterogeneous data types. Like in this case, I have passed a list which is consisting of integer as well as string data types. It is consisting of values of integers as well as string data types. Can anyone tell me what will be the answer? Like what will be the output? Will it give an error or will it give proper output? Anybody of you? Yes, Sunita ji is saying there will not be an error. So what will be the output in this case? Yes, I am waiting for the response. Participants, what will be the output in this case? Yes, you will get array. Yes, you are going to get an array consisting of these values. But have you noticed one point over here? What is the data type of values which we are getting in the output? We have passed two integers and one string data type. But when we get the output, we are getting all the values as strings because ND array supports values of similar data type. So what it has done is it has converted these integers into string data type because it supports homogeneous data type. So it has converted all the values into string data types. So it will not give an error by default. It is going to convert the values into a similar data type. So we can check if you want to check the data type of an array, you can also check. Like in this case, suppose I have stored the array in A. So we can print the array using print A command. What I have done is I am going to store this ND array into A and then I am going to print this array. It will give 1, 2, 3. And again, let's say I want to know the data type of this array. So I can write type A. So this will give me the data type of this array. So this is giving me NumPy ND array. So this means this array is of type NumPy ND array. So this was the creation of ND array using a list, 1D list. So now I'll show you how can you create a 2D array using nested list. So now I'm going to create a nested list. So this is how you can create a nested list and then you can print that list, ND array. Right? So this is your 2D array in NumPy which has been created using nested list. So this was the creation of ND array using array function. There is another function called arange. So using this function also you can create ND arrays in NumPy. So this takes a given interval like 1 and 10 So 1 is representing the start of interval and 10 is representing the end of interval range. So that means the number produced means this A range is going to return evenly spaced values within this interval, within 1 and 10. So 1 is your start of interval range and 10 is your end of interval range. And next parameter is your step size of interval. That means how much gap is there between the values it is going to return. So let's see what is the output. Let's store it in some variable and print it. So you can see that the values return will start from 1, which is the start of interval range, and the gap between the values is 2 because we have specified the step size of 2. So this is going to return values in between 1 and 10. So this is another way of creating ND arrays in NumPy. You can also specify negative range over here, like we do not want that the array should be 1, 3, 5, 7, 9. We want the array to be in reverse order. So you can write 10, comma 1 and you can write step size as -2. So then what will be the output? The array will be in descending order 10, 8, 6, 4, 2 with a gap of -2. So another function which is used in NumPy, which is quite important, is linspace function. So it displays equally spaced samples between the given interval, and the default samples which will be displayed is 50. So you have to specify first of all the start of interval and the end of interval. So what it displays is, it displays equally spaced numbers with between the given interval, and by default it is going to display you 50 numbers. So you can see that there is an equal gap between any two numbers, like there is a gap, similar gap between 1 and 1.8 and 1.8 and 1.36. So equally spaced numbers will be returned between a given interval. So let's say I want to restrict the total numbers to 20. So I should write linspace 1, comma 10, and then I need to write num is equal to 20. So now I'll be getting only 20 numbers. Another thing is, let's say I want that the step size should also be returned. So I need to write RET step is equal to true. So this means that the gap between the values will also be returned. Another parameter which you can pass is related to endpoint inclusion. Let's say I do not want that the endpoint 10 should be included in these values. Then what you can do is, you can write endpoint is equal to false, right? So in this case, this is specifying the interval. Start of the interval range is 1, end of interval range is 10. Num is equal to 20 means that in all 20 numbers will be displayed. Endpoint is equal to false means the end of interval range will not be included in these values. Return step is equal to true means that the space, the interval between these two values, the gap between two values will also be returned. So let's execute it. Now you can see that in all 20 numbers will be displayed with an equal gap, and this is the gap which is returned, because you can see there is a gap of 0.5 in between 1 and 1.5. So the gap is also returned, and you can see that endpoint in this case is not included. Our endpoint in this case is 10, and it has been excluded in this ND array values. So this is how linspace works. Now, next thing is, let's say I want to create an array of random integers. I want to create an array of random integers. So you can use np.random.randint function. So in this case, you again need to pass the interval, and you need to pass the number of random integers you want to display. So let's say I want to display 5 random integers. You can see it is going to return an array with 5 random integers between 1 and 10. So in this case, what you can do is you can also get an array of two-dimensional. Like if I write np.random.randint 1 comma let's say 20 comma 5 comma 5. So this is going to return you a two-dimensional array of size 5 into 5, and which will be consisting of random integers between 1 and 20. So this is a 2D array of size 5 into 5 consisting of values between 1 and 20. Next is you can also find out the number of dimensions in an array. Like I have created an array over here B, which is of 2 dimensions. So if I write B dot n dim, so this is going to give me the dimensions of this array, right? If I want to get the number of rows and columns present in an array, I can use b dot shape attribute of ND arrays. So this is going to give me number of rows, which is 2, and number of columns, which is 3 in this case. Now let's say I want to access some specific element of the array. Let's say in this case, in array B, which is having 2 rows and 3 columns, I want to access the element 2. So what should I write? Any of you? What should I write to access this 2? The participants? Yeah, definitely I'll be sharing my Python file with you. A12. No, Sunita ji, we are going to access the first row, and the first row can be accessed by 0 index. So the value for accessing 2, you should write A01. Right, A01. So, sorry, B01. So if I write B01, then I'll be getting 2, because it is a 0 based index. So we can access the first row or first column by writing 0. One another, so this way we can access the elements. Let's say I want to change the value of elements. So what I can do is B01 is equal to 6. So then print B. So the output is 163. So 2 has been replaced with 6. So you can just assign a new value by referring to that particular index and then assign that value. So you'll get the new array. Now you can also reshape the array. Reshape means you can uh, actually change the number of elements in each dimension. As you can see in the array B, we are having 2 rows and 3 columns. Now the number of elements will remain same, but you can change the number of elements in each dimension. Let's see how we can do. What we can do is B dot reshape 3 comma 2. So what I have done is I have now uh, increased the number of elements in the rows and I have decreased the number of columns. Sorry, I have increased the number of rows and I have decreased the number of columns. So let's say I assign it to another variable. As you can see, the number of rows have been increased. Previously, there were 2 rows and 3 columns. Now, there are 3 rows and 2 columns. So, reshape is used to make changes in the number of rows and number of columns. The number of elements, keep in mind, the number of elements will remain same. Previously, also there were 6 elements and now also there are 6 elements. So, if you, let's say you do not know, you want to create an array where you know only one dimension. There are so many elements, like thousands of elements are there in the array, and you just know that there should be 10 rows. You do not want the number of columns. You do not know the number of columns. So what you can do is you can write B dot reshape. In this case, it is must to specify one dimension. So 3 comma minus 1. So what it will give? As you can see, again it has returned an array with 3 rows and 2 columns. So that means even if you do not specify the number of columns in this case, it will automatically guess the number of columns whenever you are giving it as input the number of rows. So automatically it is calculating the number of columns in this case. So you can specify -1 in that place. Next is you can create an array with all ones. You just have to specify the number of rows and columns. So in this case, as you can, sorry, I have to put brackets over here. So this is a 3 into 3 array with all ones. So you just have to write np.ones and you have to specify the dimensions of the array. In the same way, you can display an array with all zeros. Sorry, again I have forgotten to put the brackets. So you are going to get an array of 2 into 3 size with all zeros. Another thing is you can get an array after slicing the given array. Let's say this was the array B. So I want to get partial array. Like I want only there are, let's say we talk about K. So there are 3 rows. I just want to get 2 rows and I just want to have one column in the new array. So as you can see, I have specified this is the slicing for the rows. So 2 will be excluded. I'll be getting row 0 and 1. This is row number 0. This is row number 1. And in case of column again, the endpoint will be excluded. That means you are going to get columns from 0 to 1 minus 1. That is 0 again. So I am going to get a single column, that is column number 0. So always endpoint is excluded. You are going to get the rows or columns till if it is n, you are going to get the rows or columns till n minus 1. So this is how we can get a array by slicing a given array. So there are many functions available for doing computations on these arrays. Like we can add the arrays, we can subtract the arrays. So simply I'll just show you that how can we add the arrays. The command is add, or you can simply use plus operator. So let's say this was our k array. I'll create a similar type of array. Um, let's say C is there, and I'm going to create an array which is consisting of all ones of size 3, comma 2. So C is of size 3, comma 2 consisting of all ones, and K is again of size 3, comma 2 consisting of these values. Now I'll show you how to add these two arrays. You can use np dot add, means add function I'm going to use to add these two arrays. So this will give you addition of two arrays. You can also use plus operator to add these arrays. Let's say I've stored it in h, and then I'm going to print h. So same is the answer. So you can use add function to add the two arrays, or you can simply use plus operator to add two arrays. There are other functions also for doing computation on arrays, like dot function is there. You can use np dot dot sorry, let's say k dot dot function. So using this function, you can have dot product of, you can apply dot product on two arrays. So similar way, you can multiply, add, subtract. So if you want to take the transpose of a given array, like I want to take the transpose of k, just write k dot capital T. It is going to give you the transpose of an array. One another important function is flatten function. So in case of flatten function, what it is going to do is, basically it is going to return a copy of the array collapsed into one dimension. Like here k is an array of dimension 3 into 2. So when we are going to use the flatten function over this array, it is going to return a 1D array consisting of all elements of k. Quite useful function while performing functions on arrays. So I think I have covered the frequently used functions in this NumPy. So let's move on to pandas. So pandas provides support for data manipulation and analysis. It is having two main data structures, series and data frames. Series is a one-dimensional array-like structure with homogeneous data types, and data frame is a two-dimensional array with heterogeneous data. Data in a series like this, here I have demonstrated how a series will look like. So basically series is just like a column in an Excel sheet. So this is demonstrating you, let me take the pen. So this is demonstrating you a series. It is just like a column in an Excel sheet. So these are series values. So there are 4 values in series. This is your series name, and this is representing the series index. Basically, each value is assigned an index. Like in case of arrays also, the A0, A1, these are called array indexes. So in the similar way, this is also a 1D array. So in this case, the axis labels are called as index. So this, let's say I want to refer to 2. So I can refer to this value 2 by referring to its index 2. So by default, the indexing will in this case be started with 0. But you can also assign new indexes, or you can basically change the index values by coding itself. So this is the demonstration of series. Data in a series can be a scalar value, like in this case, which can be an integer or string. So data in series can be a Python dictionary, which can be a key value pair, and data can be a ND array. So key points about series will be that it will be consisting of homogeneous data, and you cannot change the size of series. Size is immutable. You cannot change its size. Values of data mutable, means you can change the series values. So before data frames, let's have a practical demonstration of series. So let me create a new file for series. This I am saving. So this is series introduction. Now, as we are working with pandas, so I need to import the package pandas. Import pandas as PD. You can give any name. Import pandas as PD, and we need to import numpy also. So because we may be creating series with ND arrays, or we may be using this ND arrays in data frames also. So import numpy as NP. Shift enter. So these packages are included in my file. So first thing is how to create series. So for that purpose, first of all, you should refer to pandas package, and its function series should be called to create series. S is capital. PD dot series. So first of all, I'll demonstrate you how to create series of dictionary type. So PD dot series, it will take a dictionary as input. So let's say I'm creating a dictionary which is having key as different countries name, and basically what I'm putting in dictionary is country names, and this is the key value, and the pair is representing the number of COVID cases. So let's say 231 is there, then USA 560, then let's say Italy having 987, right? So what happens when we execute it? So here these are series values 231, 560, 987. These are series values. And IND, India, USA, Italy are basically representing the indexes of these values in this case. Then what I can do is, next is how can we create series containing ND array. So PD dot series, and then the input will be a nested list. So in this case, 0 is the index of first value, 1 is the index of second value. In the previous case, our value was a scalar, that is an integer. But in this case, our value is an ND array. So this is not a scalar value, this is a ND array. So data type is representing the same thing. These are integers. D type means the data type of values. So int 64 means these values are of integer type. Object means this is an object. Next is I'll show you how to create series with scalar values. That means I'll not be using dictionary in this case to create the series. I'll be using just a single list to create scalar values. And in this case, like in the previous case, when we use dictionary, it is automatically taking keys as the indexes. But in this case, there will be no keys, as this will be a single list. So in this case, your indexes will be picked up by default. So let's see how we can create a series with scalar values. So data is equal to a list. I am supplying it. PD dot series. As you can see, now the values of series are 1, 2, 3, and we have not specified an index in this case. So by default, the index values will be 0, 1, 2. Data type of the values is integer. So now what we can do is, we can also, as I've already told you, we can specify index values as well through coding. So let's say I want to specify index value as A, B, and C. So this will be again be specified using list. And now I'll be creating a series with the same data, but with explicit index values. Right. Now you can see that in the previous case, by default, the index values indexes were 0, 1, 2. But in this case, index with respect to each value is what we have provided. So for 1, the index is A, for 2, the index is B, for 3, the index is C. So next we should move on to data frames. So in case of data frames, data is aligned in a tabular fashion in the form of rows and columns. As you can see over here, the data is shown in the form of rows and columns. Again, some labels can be assigned to rows as well as columns. So here 0, 1, 2, 3 are row labels, representing row labels. Name, team, number, position, age are representing column labels. So this is your data. In this case, size is mutable as well as data is mutable. Mutable means you can change the size of the data frame and you can also change the values present in the data frame. So I'll also be providing you the website links from where you can collect the data set, because it is very much essential, because whenever you are going to do any kind of machine learning, whenever you are going to implement machine learning algorithms, you'll be requiring some kind of data sets. So I'll also be providing various websites through which you can collect your data. So the popular ones are Kaggle, GitHub, Data Driven, Data World, and the most important website is Data Search, which is provided by Google. So you can also use that website to collect the data sets. So I save it. Now I'll proceed with data frames. Again, I'll be importing pandas. Sorry. And NumPy packages. So now I'll be creating data frame using lists. So in this case, again, PD, I'll be referring to pandas package PD dot data frame function. D is capital, F is capital. Data frame, and I'll be passing a list to it. And I'll be storing it in DF. Then just print DF. So these are my 1, 2, 3, 4, 5 are my data frame values. By default, it has assigned 0, 1, 2, 3, 4 as row labels and 0 as column label. So this is actually representing your column label. And this is representing your, this 0, 1, 2, 3, 4 is representing your row labels. And these are your 1, 2, 3, 4, 5 are your data frame values. So it will be more clear when we'll be creating a data frame using nested list, because in that case you'll be having two columns, and you can see I'll also be giving some index column labels in this case, so it will be more clear. So in this case your data is in the form of nested list. So some name, right? So this I have created a nested list. Now I'll pass this nested list for creating a data frame. As you can see, these are now two columns. There are now two columns. One is with the names and another is with their age. Now, by default, again, row labels and column labels are defined using 0, 1. What I can do is I can explicitly specify the column names by writing here data dot columns is equal to, like I want to give a label as name, another column label as age. I can specify as it as a list which is given as input to columns parameter, right? So now what happens if I execute it? You can see that now the column labels have been changed to name and age. This is how we can change the column labels. Next is I'll be creating a data frame using dictionary. Again, like cases is equal to, like in case of India, like day 1 there were 20 cases, day 2 30, then day 3 40 cases were there, and so on. Similar is with USA. Then Italy. Right. So this is a dictionary. Then we are going to create a data frame using this dictionary. Now I'll show you how we can change the index values as well. Again, we need to specify the index values explicitly by writing index is equal to a list of index values. Index is equal to, let's say I want to assign indexes as R1, R2 and R3. in this case, you can see that the key values of dictionary have become column labels, and the values corresponding to each key have become values corresponding to that particular column. And as we have explicitly specified index values, so indexes have been assigned to each row. R1 is for first row, R2 is for second row, and R3 is for third row. This is how we can assign index to every row in the case of data frames. Now, simple attributes we can find out with respect to these this data frames, like we are having this data frame with us, or we have, let's say, got a data set and we have retrieved that data set in my file. So I want to know the number of columns and number of rows of that particular data set. So I can simply write df dot shape, right? So that will give me the number of rows and number of columns present in that data frame. Now let's say I want to know about the column labels. What are the column labels? So I can write df dot columns. So this will give me the column labels of the data frame. Similarly, len function can be used to know about the number of rows. If you just want to know the number of rows, and if you want to just know the number of columns, you can write len df dot columns. So this will give you the number of columns, right? So this was about the basics of data frame. Now I'll show you how can we perform data exploration using this data frames over a real-time data set. So I have downloaded a real-time data set related to COVID cases in India. So that has been stored in some CSV file, which I have downloaded from Kaggle. So what you can do is, first thing is to read that data set into my file. So for that purpose, there is a function called read. If it is a JSON file, you have function read underscore JSON. Otherwise, there are various functions available. Like if you are going to read CSV file, the function is read underscore CSV. For reading Excel file, the function is read underscore Excel, and so on. So in this case, I would be calling function read underscore JSON as my file is in JSON format. So basically, usually the files are in Excel format. Dataset is usually provided by websites in Excel format, JSON format, or in CSV files. So this is in JSON format. You just need to write this function and pass the file name. The file name is dates underscore daily dot JSON. So this is my file. If I want to store it in a data frame, what I need to write is just I need to write df is equal to pd.read JSON. So this whole data set will be stored as a data frame in this variable df. So just execute it. So that by executing this command, I can store whole of my data set in the form of data frame in df variable. So now you should know that where to actually store this file in your computer, in your system. So you need to store this file in the same location where your present file is there. So the location of present file is actually, you go to your C drive. In case in C drive, you have to access the users folder, users. And in this case, you have to access the username in which you are working. Like in this case, this is the username. And then you have to access the folder in which your current files are present. So in my case, it is my Python programs. So here I am storing all my files along with the data sets. So I am accessing this data set, states underscore daily.json. So data sets and all my files are stored in this particular folder. So path is C drive, users, and the specific username in which you are working, and then the specific folder in which you are working. Just put your data set, data file in this particular folder. Then you can directly access it. Otherwise, you have to specify the full path name for this particular data set. So now we have accessed our real-time data set related to COVID cases in my DF data frame. Next is I would like to see, like in the previous command also I've seen like what type of data is present in this particular data set. So now let's say I want to focus on some of the samples of this particular data set. So you can use the command df.head. So this is going to return you the first n rows of the data set. So by default, in this case, n is equal to 5. So by default, head is going to return the first 5 rows of the data set. So as you can see, what it is showing is, what data it contains is, it is containing the number of confirmed COVID cases, the number of recovered COVID cases, and the number of diseased COVID cases for each state. AN, AP, these are the just the short names of each state, like CH is representing Chandigarh, DL is representing Delhi, and so on. So it is representing the confirmed, recovered, and diseased COVID cases with respect to each state, and it is also representing the date on which these cases occur. So basically, as you can see in this case, it is representing the data starting from 14th
Ma'am,
March.
sorry to interrupt.
Yes, ma'am.
Ma'am, can you please repeat this head again? DF dot head.
Pardon, ma'am. Please repeat.
Uh, Ma'am, can you please repeat the DF dot head again?
Yeah,
I
yeah,
couldn't
sure,
get it.
sure. I can repeat.
Yeah, thank you, ma'am.
So df.head is going to return first 5 rows of the data set. So by default, it will be returning first 5 rows. But you can modify, you can increase the number of rows, you can decrease the number of rows. Like I write df.head and in the bracket I write 7. So by executing this command, you'll be getting first 7 rows of the data set. So you can increase the number of rows and decrease the number of rows by specifying a number over here. So
Thank you, ma'am. Thank you.
okay, welcome. So as we can see, when we have executed this command, number of rows and number of columns are being displayed here. That means this data set is consisting of 303 rows and 41 columns. Out of these 41 columns, one column is of status, that is representing whether this row is for confirmed cases or recovered cases or diseased cases. And one column is for date. So rest of the 39 columns are actually representing the states. So date is actually on which date these cases occur. So as you can see, the data is starting from date 14th November 2020 and the data is ending at 22 June 2020. So that means this data is from, this cases are from 14th March 2020 to 22nd June 2020. So this data is between these dates. So using head, we can retrieve the first n rows of the data set. In the same way, we can retrieve some of the last rows of the data set using tail function. So if I write df.tail, So this is going to give me last 5 rows of the data set. If I write df.tail again, if I pass 9, then it is going to give me last 9 rows of the data set, right? It is going to give me the last 9 rows along with all the columns of the data set. So this is how we can retrieve some of the sample rows of the data set to know about the data, what it is consisting of. Then again, if you want to specifically, explicitly retrieve the number of rows and columns, you can use df.shape. It is going to give you the number of rows and number of columns. 303 rows are there and 41 columns are there in this data set. Then next is, let's say I want to see, like in this case, we are not able to see the column names, column labels for some of the columns. So we can get the column labels by writing df.columns. So this is showing you that what are the different column labels it is consisting of. A and AP, etc., etc. And there are just 2 columns which are other than the states. One is states and other is date. Rest all are representing the name of the states. Then next is df.info command. df.info. Basically, it is going to display information such as number of rows and columns, total memory usage, data type of each column, and number of non-null elements. So you can see over here, this is representing the column names, number of non-null elements, data type of each column, and the memory usage of this data frame. So this is how you can know your data. This is how you can retrieve the stats. And I'll tell you how we can retrieve the stats regarding this data also. Before that, we are just knowing about our data, what type of data types it is having, what, how many non-null objects it is consisting of, and all. So next is df.isNA function. Using this function, you can find out, is there any value which is missing, which is NA. So if the value it is returning is false, that means it is, the data is present in that case. So if any of the value returned by this function is true, so that means that particular cell is having missing value, or that particular cell is having any value. So as it is returning all false values, so that means this data set is not having any missing value. So df.isNA function is used to find out the missing values in the data set. Next is, let's say I want to, till now we were working on the whole data set. Now I'll tell you how can we retrieve specific rows, how can we retrieve specific columns. Let's say I want to just work on the COVID cases related to Delhi, or related to Chandigarh, related to Maharashtra. So how can we retrieve data related to a specific column or a specific state in this case? So I should write df scare brackets and then the name of the state, df dl. So I want to retrieve some of the top rows of this data set related to Delhi. So I should write df. In the scare brackets, I need to write dl dot head. So this is going to give me the cases related to Delhi only, right? So let's say I want to display, I'll show you later on. First of all, I'll want to show you how to retrieve rows. Like I have demonstrated you how to retrieve data pertaining to a particular column. So I'll show you how to retrieve data related to particular row or particular value. How can we retrieve? So let's say I want to retrieve data from row number 302. So I have to call function df.loc. df.loc. Then I need to pass the row number. So this is going to give me the cases or the values present in row number 302. Right? So this is how we can retrieve a particular row. This is how we can retrieve a particular column. We can also retrieve a particular cell value. Like if I write df.log 302, Andhra Pradesh. So what I want to retrieve is the data of or the cases of Andhra Pradesh which are present in row number 302. So this is my row label, row number or row label, I should say. This is my column label. So there are actually two functions. I'll be demonstrating you both of these functions. So keep in mind that LOC function is used to retrieve specific rows or specific cell value, and we have to provide labels as input to this particular function. Labels as input to this particular function. So as I've specified AP. So this is a column label. 302, this is a row label. So this is going to give me particular cell value pertaining to these row and column labels. There is another function ilog, which is also used for selecting data from the data set, but it takes input as integer index. Integer values it takes as input. Like in this case, I want to retrieve, let's say same data I want to retrieve, right, of row number 302 of Andhra Pradesh. But in this case, I need to pass the column number. So let's say AP was belonging to, this was column number 1. So I can write 302, 1. So here I have not specified column label. I specified column number, and 302 is again because index values are same as row numbers, so 302 is again row number also. So df.ilog 302, 1, this is going to give me again 5, but this function is going to take index row numbers and column numbers for giving output. So ilog can also be used along with slicing. Like I write df.ilog. So sorry, square brackets. So in this case, I would write, let's say 0 to 2, comma. So what it is going to give me? It is going to give me the data of 0th and first row, and columns, as I have not specified initial value, so it is going to start from 0th column and will give the values till 3rd column, that is 4 minus 1. So as you can see, row number 0 and 1 and column number 0, 1, 2, 3. Up to 3rd column, it is going to display the values, right? So next is another most important function, which is going to display display the descriptive statistics of the data set, is df.describe function. Quite important function, df.describe function. So you can see it is going to give you the descriptive stats of the data set. Count, count is the number of non-null values with respect to each column. And keep what I want to tell you is the main point here is that it is going to give this descriptive stats with respect to numerical columns, right? So all of these columns, as you know, were consisting of integer values. That means they were belonging to numerical values. So that's why it is giving descriptive stats of all these values. If you specify include is equal to all here, then it is going to descriptive stats of all the columns, whether it is categorical values, whether it is having categorical values, whether it is having numerical values, all of the columns. But in case of categorical values, the columns which are consisting of categorical values, in that case they will be having descriptive stats of NA with respect to mean, standard deviation, means whatever values we cannot calculate over categorical columns, they will be demonstrated as NA. So in this case, count is actually showing you the number of non-null values present in this column, mean values, average values of this column, standard deviation, minimum value in this column, then 25 percentile, 50 percentile, 75 percentile, and maximum value present in this column. So this is demonstrated with respect to each of the column. So if you want to extract descriptive stats or of some particular column, you can write df, like dl. In case of dl, you can write dl dot describe, right? It will give you descriptive stats with respect to dl. So you can easily analyze the number of non-null values in this column, mean value of this column, standard deviation, etc. with respect to some particular column if you want to focus on Delhi. So it will be more clear in this case. So next we actually come to how can we analyze data from this data set. So very first thing is I would like to show you like we want to focus on number of confirmed cases in Delhi. So if we write df status df status is equal to confirmed. So what it is going to display. As I have given a condition df status is equal to confirmed, so it is just going to give me true and false value because this is a condition. So it is going to give me the values, like for 0th row it was true, like it was consisting of confirmed cases. In the case of row number 1, it is with respect to recovered cases, so it is giving me false value. Again, row number 2 is with respect to diseased cases, so it is giving me false. Row number 3 is with respect to confirmed cases, so it is giving me true. So wherever the value of status is equal to confirmed, equal to confirmed, it is giving true, otherwise it is giving false. Now, how to retrieve the rows where the confirmed cases have been given? So I need to write df, and in the square brackets I have to put this condition, right? I have to put this condition, df status is equal to confirmed dot head, just to get first 5 rows. So now, as you can see, it is giving me first 5 rows where the status is equal to confirmed. Is it clear to all that this is the condition where I have said that I want to retrieve the rows where the status is confirmed, and Then I have passed this condition to data frame, and it is going to return the number of rows because I have called dot head function. So it is going to return the first 5 rows of the data set which are fulfilling this particular condition, right? So next is, again, I would like to see the number of cases. I don't want to see the number of confirmed cases of all the states because it is quite difficult to analyze, because some of the columns are missing in this case. So I'll focus on some particular state. So again, I'll write the same thing. But in this case, I'll write the, right. So this is going to show me the number of confirmed cases with respect to Delhi, right? But again, the problem is that I am not able to find that on which date these cases occur. So what I can do is I can add date over here. Date, right? For adding date, as now it is consisting of multiple columns, so it has to be put as a list. So this has to be put in the square brackets, right? Now I want to see, let's say, last 10 rows. Fine. So what I have done is data frame. I want a data frame where this particular condition is true, and that data frame is only consisting of these 2 columns. Dot tails 10 means it will be having only the last 10 rows of the whole data set, right? So let's execute it. You can see it is consisting of last 10 rows of the data set and comprising of only 2 columns, DL and date, and these are the confirmed cases of this particular state on these dates, right? So we can easily now analyze. As I've told you, data exploration means you are analyzing your data, you are knowing your data. So you can know that on 13 June there were 2134 confirmed cases in Delhi. On 17th there were 2414 cases, confirmed cases in Delhi, right? So this is the analysis of your data. Next is, let's say I just want to see the number of cases which are greater than 3000. So I just want to demonstrate you how can you use uh, complex queries, complex conditions. Like there was, in this case, there were only one condition, DF status is equal to confirmed. Now I'll be showing you how to use a complex condition. So I'm going to put this DF status is equal to confirmed in round brackets, and then I'm going to use AND operator, right? I want that number of confirmed cases. I want only those rows where the number of confirmed cases are greater than 3000. So I would write in the round brackets DF DL greater than 3000. So I have written 2 conditions in round brackets. One is DF status is equal to confirmed and DF DL is greater than 3000, right? Then DL date and dot tail 10. Parenthesis is missing somewhere. This parenthesis is missing, right? So it is demonstrating me the cases where the number is greater than 3000, and these are confirmed cases. So we can see that on 19th there were more than 3000 cases in Delhi, and on 20th itself also there were more than 3000 cases in Delhi. So in this way we can analyze the cases, the dates where the cases were more than 3000, or we can specify any number. Next is we can, like we have seen the descriptive stats where we were seeing the count, max, min, etc. So if you just want to know the maximum cases, you can explicitly use function dot max also, right? Rather than getting whole descriptive stats, if you just want to know the maximum number of cases or maximum of value in some column, you just write dfdl or the column name, then dot max. So max will give you the maximum value present in that particular column, right? Then so there are so many functions I would like to demonstrate. Let's say I want to see this was the maximum cases in Delhi, but I want to see maximum confirmed cases in Delhi. So I would write again the same thing. Sorry, this one I should pick. Right? Status confirmed, DL, date, but rather than getting all the rows, I don't want to get the last 10 rows. I want to get the maximum confirmed cases in Delhi. So the condition is status should be confirmed. I want to get the cases of Delhi. I also want to know the date on which those cases came, and I want to know the maximum number of confirmed cases, right? So the maximum number of confirmed cases in that duration were 3630, and that came on 22nd June, right? So this is how we can get the some particular stats related to a particular column. In the same way, you can replace confirmed with recovered with diseased. So you are going to get the maximum diseased cases in Delhi. You can get the maximum recovered cases in Delhi. So this is how you can perform summarization or stats on your data. So I think time is getting over. So there are so many actually functions which I would like to demonstrate you. If time would have permitted, I have demonstrated you. But I think the time is over. So I would like to ask you that if you are having any queries, you can ask.
Participants, any query, please?
Stuck in question. We have a CSV file called people.csv. The data has 3 columns. It looks as follows. Write the code to load the data as a pandas data frame. That I have demonstrated you, na? You are asking how to load the CSV file as data frame. So I have demonstrated that part. Here it is. Like rather than using read JSON function, we can use read CSV function. I've shown you. Let me show you again. PD dot read underscore, you can press tab to know the available functions. So you can use this function pd.csv Then you can pass the name of the file, name of CSV file, right? And if you store it in a data frame variable, it will be stored as a data frame, right? For visualization, matplotlib is there. You can use that library. So using that library, you can plot various types of graphs. So that is another session. That is another full-fledged session using a demonstration of that matplotlib library. So participants, if you have any more queries, you can ask. Otherwise, we can wind up the session.
Now, I think there are no more queries. Thank you very much. Thank you, Mala ma'am, for a very wonderful session and the clear exposure to all the participants for Pandas and NumPy. It was really a wonderful session, and I hope the participants must be benefited with it. Thank you, ma'am. Thank you for your presence.
Thank you, ma'am. It's my pleasure. Thank you so much, ma'am.
Thank you, participants. We will be rejoining at 2:30 after the lunch.
Okay, thank you all. So can I leave the session, ma'am?
Yes, ma'am. Thank you very much, ma'am.
Thank you.